Hey guys, so sad that I have to redo this again because somehow my screen was not recorded. I explained quite a bit, but now I reset all these problems. So this is basically the binary from blind curated 75 problems, which I'm just going to do again. Uh, I resetted the whole thing. Okay, so 32 bits unsigned integer will be, say, simply I so we have this number. How will we reverse it? So to reverse this last in LSP should be MSP, right? So this zero should, let's just think about simple number 1011, right? So this one should come here, then next one, then 0101. So the reverse of this is this, right? So to do that, what we'll do is we'll first take this value and then put it here, right? And then put it here, then right shift it one time and then add the number. Again we remove this, put here, remove this, right shift and do it like this. So left shift, right shift and left shift. So basically what I mean is, and since there are 32 bits, so for int I equals 0 till I less than, not and but 32 I plus plus, because there are 32 bits again. So let's say we have int r equals to 0, then so our int current value equals to n and 1, right? Whatever the value is our current value, now which will be either 1 or 0, right? So now, and then we can do n will be right shifted to 1, so we will throw this one away, and then this r will be left shifted to 1, whatever is there. Then on that we'll simply add our current value, right? Like I explained below, and then simply return current value. Oopsie. Oh, r. Yeah. And then number of 1 bit. So again this is something similar. So here also for int, so here we need to find the number of ones in this, right? So for int I equals to 0 to I less than, this is also 32 bits, so plus plus, and int count bits equals to 0 and return count bits, right? So what we'll do is count bits is equals to n and 1. So if it is 0, then the addition will just be 0, so there is no check like if else, right? And the other thing we'll do is we'll simply right shift this by 1. Let's just run a test. Okay, I think we should be good. Yeah, here I explained something about the signed and unsigned bits, but that's fine, you can. Okay, missing number. The missing number, this number is like, so one thing we need to know is 1 XOR 1 is 0, 2 XOR 2 is 0, right? Similarly 3 XOR 3 is 0. Here every number is given from 0 to n, that is, and one number is missing, right? So ultimately what happens is, if there are 3 numbers, then so we have first index 1, which has, or 0th index which has 0. Similarly we have first index, let's say it has value 1 or 2, anything, and then XOR the third index with value 2, right? Something like this. Then what is the missing number? 0, 2 and 3. 1 is the missing number, right? And then since there are 3 numbers, what we'll do at last, we'll also XOR 3. So what happens now is, if you look at this number, 3 and 3 is repeated, 2 and 2 is repeated, so all of this will be 0. all of this will be 0. So 0 XOR 1 is 1, so 1 was the missing number, right? So that is what we'll do here, basically. So let's say our int val equals to 0, or return anything is 0, then for int I equals to 0 till I less than noms dot length I plus plus, what we'll do is our return will be XORed against this 0 will be XORed against the value I, because this is our index, and the value at that number, that is nums of I, right? So if you think about this, we have rate as 0 at first, and then I as also 0, and num at index 0 is 3, right? So this will give us 3. So on the second iteration, what happens is rate is 3, XOR I is 1, and nums at 0 is 0. So this is XOR 0. So this is our rate on the second loop index 1, right? And then loop index 3 will yield, this is our rate XOR not 3 but 2, 2, and then on index 2 what we have is 1, right? So 1 1 0, so this will yield something like 3 XOR 2, XOR 1 and 1 is 0 and 0 is 0, so 0, right? So now our total length is 3, so if we simply XOR this with 3, that is 3 XOR 3 is again 0, so it will be 0 XOR 2, which will be 2. So our answer will be the missing number, right? Return XOR noms dot array. I hope this time my screen is recorded. I'm recording from Mac, so it is actually recording now. Even previously it was recording, but it just had my voice on, and the screen it was capturing was something else. So now if I want to check this, I have to stop and see the video again. So I tried that and it worked the next time, so I hope this works again. Okay, counting bits. Okay, we are on fourth, that is counting bits. So given a non-negative integer num, for every number from 0 to num, calculate the number of ones in its binary representation. Okay, so yeah, this problem is like, so we have rate as to, let's say int array return is equals to new int array of num plus 1, right? Because 0 1 2 3 values we need to return. Just think about this. We know that 1 right shift 1, anything right shift 1 will move the bits to the right. That is basically doing like half, right? If you think about this, 1 0 0, which is 4, right shift 1 means this will yield 1 0 0. This 0 is lost, right shifted one time, right? And there is nothing, so this just falls off, and the remaining is 1 0. So basically if you think on digital notation, I mean, so this is like 2 power 0 1 2 times 1 plus 2 power 1 times 0 plus 2 power 0 times 0, right? This 1 0 0. So this will basically be 4. 2 power 2 is 4, and 2 power 1 times 0 is 0, 2 power 0, which is 1, times 0 is also 0. So altogether this will be 4. So this is 4, and the half of 4 is 2. So right shift anything, any number, right shift 1 means it is divided by 2. Similarly, any number left shift 1 means the result is 2 times the number, right? Okay, you got the idea why also, right? Because we are adding one more bit and it will increase the power, so times 2. So now for int I equals to, now again we have 0 1. Let's think about this. We have 0, we have 1. The number of bits on 0 is 0, the number of bits on 1 is 1, right? The number of bits on 2 is, which is 1 0, is also 1. Then similarly we have 3, which is 1 1, 4, which is 1 0 0, then 5, then 6, then 7, then 8, right? So now if you look at all these numbers, the 0 is 0, so we can simply return, okay, return rate. For int I equals to, so we'll simply go from 1 till I less than or equals to num, yeah, and then I plus plus, right? So now here what we'll do is, if you see this return at I, if you want to count this, since the 8 is 4 times, so if you look at this will be 1 0 0 0, this will be 1 1 1, this will be, how much will this be, 1 0 1, so this will be 1 1 0, right? So if you look at this, all the odd numbers, that is 1 3 5 6 7, there are, and then all the even numbers 2 4 6 8. So all these even numbers have 0 at last, and all the odd has 1, right? So we can simply say if the number has odd or even, then we already have one value, that is I and 1, right? If we just do the AND with 1, 1 and 1 is 1, 1 and 0 is 0, so we have one count. Then the additional is, if you look at this, if we just right shift this number 8, the least significant, we are already considering this number, right? We already considered this number with this, so right shift 1 will yield 0. So this is all right shift 1, 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 right shift 1. So this is 4, right? This is, how much is this? 3, right? So basically if the number that we want is the half, right? The number that we want, the remaining is just the half. That is basically what I mean is I right shift 1. I mean, this number when right shifted 1 will be 4. The number of 1s in 4 plus the additional number here, right, I and 1 that we have, right, will give us the total number, that is the 4 will have 1 because 4 had 1, and this 4 had 1 because this 4 came from 2 which had 1, and this 1 came from 1, right? So that's how it will progress. I hope you got it. Basically what I mean is any number 8 or let's consider 2 examples, 7 will be, since this is 1 0 0, which is, if you look closely, this is 1, when right shifted it will be 100, and then the extra bit is 0, and since this extra bit, which is I and 1, is already 0, we don't want to consider this, so this is already 0. The remaining is just the values from 4, right? Since I is 8, since I right shift 1, I right shift 1 means I by 2, that is read 4, so this will be 4. So the number of 1s in 4 is the numbers of 1s in 8. Now for 7, what happens is it is 1 1 1, so we already know this is 1 1 and 1, and we have already taken into consideration the fact, we already considered that 1, since this is odd, this will have 1 extra 1, so we counted 1, and then the remaining number is just the half, which is 3. So number of 1s in 3 was already computed, which is 2. So 2 plus 1 will give 3 as the result. So that's how it is calculated. And if you look at the very base numbers 0 1 2 3, this is 0. Since this is odd, it will be 1. Since this is even, the 1 0, the I and 0, this part will give 0, and 2 by 2, which is 1, will give 1, so the value will be 1. And 3 is computed, saying okay, 3 is again, this will give us 1 here already. The remaining is 3 by 2, which is 1, which gives us 1. So 1 and 1 will be 2 for 3, right? So this is how it will be. So when I submitted it earlier, okay, when I submitted it earlier, the problem was I didn't have this bracket here, so that was the error. Okay. Now calculate the two sum. Okay, again, now we have A and we have B, right? We have A and we have B. We need to sum these two. Our basic, if we just do a multiplication of these two numbers or addition, what do we do? Let's say this is 6 and this is 5 and 7. So if we simply need to add these two numbers, we'll do 7 plus 5 is 13, that is 2, and with a carryover of 1, right? So 3 3 6 and carryover, so this will be 7. 3 2 and 1 is 3 3. So this is the result, right? This is how we do, we have a carryover. So now, and if the whole of this number is 0, then just A will be the number. That is, if, let's say, if A equals to 0, then return B. We can simply say, okay, return B. Or if B equals to 0, then return A, right? Because that will be the sum. Now, since we are doing something like this, right? So since we are adding these two numbers, what happens is we need to find out the carry, like previous, and the sum. And so to do the carry, if you look closely, what happens is, to do the carry, right? So if we have 1 and 1, the carry will be 1, because 1 and 1 is 11. So the carry will be 1, right? And the sum will be, for 1 and 1, it will be 0. So if you look closely, if, let's say, and then 1 and 0 will have a carry of 0, because it won't have a carry, it will simply add up. And if it has, so basically if 1 and 1 is going to be added, then it will yield 1 as a carry. If 1 and 0 or 0 and 1 is going to be added, 1 and 0, then it will yield 0 as carry, right? So that means this is basically an AND operation, right? So AND carry is A and B, right? Now now the sum. Now if we do this carry, let's say we have some carries here. This is not exact, but just okay, let's say this was the carry, and then how do we do the sum now? The sum will be, so if this is 1 and 1, if both are 1 and 1, it will be 0, and 1 is the carry. And if this is different, then simply 1 will be here, right? So that means 1 and 0 should give us 1, and 1 and 1 should give us 0. This is what the sum will be, right? So to achieve this, what do we do? 0 and 1 will also give 1, and 0 and 0 will give 0. So what does this look like? This is the XOR, right? So int sum is equals to A XOR B, right? So this is our sum. And now whenever we did this and sum this, we have a sum here and we have a carry here. Now how about we just add sum and carry again? Sum plus carry, this will give us the final result, right? So similarly we can do this, return get sum of sum and carry. So I submitted this just before, and I had the error. I mean, whenever I was about to submit earlier, the error was, if you look closely, again in the small numbers, so let's say this was 9 and this was 3. What we do is whenever we are adding these two numbers 19, 11, 12, the carry is left shifted, right? So 1 will go here. So similarly this carry also should be left shifted, because we cannot just do the whatever is here 1110 1100, whatever number we set came from the carry should also be left shifted, right, one time at least. And that's how we get this. Okay, so like it's okay. So I had a wrong answer here. If you look this gave me 5 earlier, because I was not shifting the carry, right? uh, okay, now finally we have a peak. Find index in a mountain. So this is basically just the binary search. This is not from the blind curated problems, but I added it here. So here what we need to find is the peak number. So this is the peak number, right? The rest is all small. Here 5 is the peak. So here it says that the number increases first, and after some point it starts decreasing at some point I, right? So and then so array is guaranteed to be a mountain array. So basically what we'll do is we'll simply do a binary search and find the peak. That is, we start at 0 and we can do a linear time search saying, okay, did the next right element is smaller than the current element, then yes, this is the peak. That's how we can do. But yeah, that will take O of n time. So we simply want to find it without in log n time, in logarithmic time, and not in linear time. So now what we'll do is, okay, while low is less than high, right, what is our midpoint? Our mid is always do this, which I told in my previous video also, by 2, because this won't overflow, right? So once we have the mid, let's say this is our mid, then what are the conditions? If this value, that is ARR mid, if this array mid is smaller than the next element, right, is smaller than the array of mid plus 1, that means this current mid is not, this is not the peak element. This can be the peak element. So what we do is, okay, let's just assign this low, and we can just continue to look on the right side because this is increasing. So low will be mid plus 1. And if this is not the condition, that is, if this if mid plus 1 is not greater, but if it is smaller, that means uh, that means the high point can be this, right? It can start to decline from here also. So our high will be the mid. This is just a binary search, guys, and then we simply return the point. Okay, cool. Thank you, guys. We did all these binary problems, and then on my next videos I'll do some other type of data structures and algorithms. Thank you.